Okay, so let's go ahead and look at the first review packet for our final review. In the first problem, we're asked to write the following parametric equations in rectangular form. So we have to basically reduce two equations into one equation, and it's going to start out with something that says y equals. So in order to do that, we have to do what's called eliminate the parameter. So I'm going to take this first equation, x equals 3t. I'm going to solve this for t, and then I'm going to substitute the result into the second equation. So if you solve this, it's a pretty easy equation to solve for t. We just divide by 3 on both sides. You get t is equal to x over 3. I'm going to take this result, like I said, and I'm going to substitute it in where I see the t in the second equation. So what we get is y equals, you know what, let me come over here and do that instead. I'm going to run out of room. What we get is y equals negative 10 x over 3, that whole fraction being squared, plus 7. So now, just remember, when you simplify something like this, okay, sorry about that. When we simplify something like this, we get y equals negative 10. We have to do the exponent here first. So we're going to get x squared over 9 plus 7. Now we distribute the 10 through into the parentheses after we've done the exponent. And we'll get a final answer of negative 10 x squared over 9 plus 7. Okay, so the second, or part B I should say, is exactly the same. Equations look a little bit different, no exponents this time, but I'm still going to start out with the first equation and solve it for t. If I solve this first equation for t, I have to first subtract the 1 and then divide by 4. So t is equal to x minus 1 all over 4. I'm going to take this result and I'm going to substitute it into the second equation. What I get is y equals negative x minus 1 over 4 plus 2. Now sometimes we'll just leave it like this, but if it's a multiple choice, they might simplify it a little bit. So what I'm going to do here is apply that negative that's on the outside of the parentheses, and I'm also going to split the fraction. If they're both numbers here, the 1 and the x are being divided by the 4, so I can do that. So I have negative x over 4 plus 1/4 plus 2. Again, I applied that negative to both terms, the x and the 1. So if we do a little bit more simplifying, we get a final answer of y equals negative x plus 4. Combine our like terms, the 1/4 and the 2. I like fractions, so I'm just going to stick with that. 1/4 plus 2 gives us 9/4. Alright, let's move on to a different type of problem involving triangles. Now, just a little reminder that when we're talking about sine, cosine, and tangent, it's SOHCAHTOA. This will help us remember that sine is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. And tangent is the opposite over the adjacent. So I'll insert a few equal signs here and remind us how the equations are set up. Another thing I want to point out though before we even begin is that we have 2 theta here. So it's not just simply a sine of theta, it's sine of 2 theta. So there's actually a special formula off our identity sheet that has this formula on it. The formula looks like this. Sine of 2 theta is equal to 2 times the sine of just theta by itself times the cosine of theta by itself. So what do we get? We get 2, the sine of theta. So if we're looking at this angle right here, the sine, the opposite side is the 7, and the hypotenuse is 25. So I'm going to plug those numbers in, 7 over 25. I'm going to multiply that by the cosine of theta. Problem is we don't know what the adjacent side is yet, the A that I have labeled in the triangle. So I need to use a Pythagorean theorem in order to figure out what goes here. A little question mark there for now. So I'm going to come over here and I'm going to write 7 squared plus b squared equals c squared, 25 squared. We subtract the 7 squared from both sides, or really this is just 49, we get b squared equals 576. Take the square root of that and we get the adjacent side is equal to 24. So that's what I'm going to plug in right here. If you plug that in your calculator or do it by hand, you get 336 over 625 for your final answer. Okay, moving on to number 3. So every problem number 3 involves the identities. So just a reminder that you might want to put on your cheat sheet for the final exam some of the identities mentioned in the review packets. You don't have to put every single one on there, but the ones mentioned in the review packets, I would strongly suggest that you put that on your cheat sheet. So here we go. So I'm going to start by simplifying part A. Cosine of theta being multiplied by the secant of theta. Well, what's the secant of theta? That's just 1 over the cosine of theta. The cosines cancel out, and we're left with just 1 as our final answer. Pretty easy. Now, moving on to part B. Take a close look at your identity sheet. You'll see under the Pythagorean identities that you have this identity, 1 plus the cotangent squared theta equals the cosecant squared of theta. So if we manipulate this a little bit to make it look like this guy here, what we get when we subtract cotangent squared from both sides, you get the cosecant squared minus the cotangent squared theta, and all that's left over on this side would be 1. So this, just like part A, is only equal to 1. Final answer. Okay, moving on. Typically when they ask you to simplify, they want you to either write it in its simplest form, which that's kind of obvious, or they kind of want you to reduce it to only one identity or one trig function, like sine, cosine, tangent, etc. So in this problem, you have cosine of theta. I'm multiplying by cosecant of theta. A lot of the times it helps to write our trig functions in terms of sine and cosine. So I'm going to write this as 1 over its reciprocal. The cosecant of theta is just equal to 1 over the sine of theta. We rewrite this as one fraction. We get cosine of theta over the sine of theta. And if you take a close look at your formula sheet or your identity sheet, you'll see that this gives you the cotangent of theta. So, depending on the directions and how specific they were, this would probably be the most simplified version. Okay. And moving on to the last one, again, which will come from the identity sheet under the Pythagorean identities, this right here is just equal to 1. So this one should be really simple. So Pythagorean identities, the reciprocal identities, and the quotient identities on your formula sheet are probably the most important, the ones you really want to focus on getting a hang of. Write the equation of the parabola with given directrix and focus. So this was in the last unit of what we covered in our class, Unit I. What I'm going to do is first kind of sketch a picture of what this looks like. It says that we have a directrix of y equals 6 and a focus point of 1, 2. So our directrix is going through the y-axis at 6. Okay? The focus is at 1, 2. So I go over 1, up 2. I'm going to label that as F. It's really important to label it with what it is, because sometimes you might, on accident, draw the parabola through that. Remember, the parabola goes through the vertex, not the focus. So now what I do to find the vertex, because that's what I need in order to write the equation, is I take the distance between the focus and the directrix line, split it in half, and that's where my vertex is going to be. So if you count tick marks, we have 1, 2, 3, 4 spots. So that means the vertex is dead center at 2 spots. So what we have here is a vertex going straight down. And when we have a vertex that's going either up or down, the general form of that is x minus h squared equals 4p y minus k. So I'm going to just substitute some of my letter values in, my x, my y, and what this p-value is. The p-value is just how far the vertex is from the focus point, or the directrix. So I have x minus 1 squared equals 4 times p. P we said was 2, but this parabola is facing down, so it's going to be a negative 2. Y minus 2. Again, the vertex was 1, 2, so we put the opposite values in the first set and the second set of parentheses. That's our final answer. Okay, let's take a look at part B. Part B is very similar. They give us the directrix and focus once again. Hint, hint. What might be on your test? Anyways, if we go ahead and sketch ourselves a picture again. 1, 2, 3, 4. Here's my directrix line this time. Okay. My focus point is at 2, 2. And then again, I have to count dead center in between. So there's 1, 2, 3, 4, 5, 6 spaces. That means 3 spaces is dead center. So I'm going to count backwards towards the directrix line from the focus point, 3. So here's my vertex. So this time we have a parabola that's facing to the right. Anytime we have one facing to the right or the left, we have the equation that looks like y minus k squared equals 4p x minus h. My vertex, just to make a note of that, is -1 and +2 this time. So my final answer, I get y minus 2, because that's my y coordinate, equals 4 times p. P in this case we said was 3. And it's +3 because it's opening to the right. And then we have x plus 1, because I said before that it's the opposite of what's in the parentheses. So since there's a -1 in the parentheses, we put a +1.